Hello guys, today we will study about kinematics and the topics will be average velocity, instantaneous velocity, and acceleration. So yeah, average velocity is denoted by this symbol. This is v, this is vector, and this is symbol of average. And with for instantaneous velocity, this is the symbol, and for acceleration, it is the symbol. Then average velocity is actually average displacement by and change in time. Average displacement in that time being, that is delta t. It is called average velocity. And now instantaneous velocity, that would be limit tends to 0 delta s by delta t. Instant, if we talk about an instant is really small, so t is similar to 0, so we use this limit that we study in calculus, so that is equivalent to ds by dt. So now we will see the formula acceleration. And now average acceleration. First average acceleration, same, this is the symbol, and this is the velocity change in velocity in this time being. And for instantaneous acceleration, it is same, limit t tends to 0. If we can write delta t, because we have written delta t here, so it would be delta v by delta t. Sorry, you should use this vectors. Yeah. This is important because this is a vector quantity, so this would be by dt. Yeah, we can take up a question as well, we can discuss another thing. We have discussed average velocity, instantaneous velocity, so we can also see average speed. What is speed? Speed is a scalar quantity, and instantaneous speed, so it would be denoted by this average, and this is v, there is no vector, it is called a scalar quantity, and this is instantaneous. So you can we can see here, delta v is equal to same like previous. This is a distance, this is displacement, this is distance. We had studied distance and displacement in the previous lecture, so I will not talk about it now. So now if we see instantaneous speed, it would be, so for instantaneous we can write same, delta s by delta t, limit delta t tends to 0. and it would be ds by dt. Yeah. So if you write the definitions, this would be, it is the average displacement covered in a time delta t, and this is the rate of instantaneous velocity. This is the rate of change of displacement, and this is the average distance. This is an important term, covered in time delta t, and this is rate of change of distance with respect to time, and here also with respect to time. If we write about acceleration, for average acceleration it would be same, like it is the average change in velocity in a delta t time, and also for instantaneous rate of change of acceleration, velocity with respect to time. We can see an example. This is an example, like v is given, like sorry. So I have written down the question. Instantaneous speed, we have got t I cap plus t square j cap. This is the vector notation, as we know. Particle is in the xy plane, so we have to find out the distance and displacement, and we have time to 0 to root 3 seconds. Okay, so then we know that delta v velocity is equal to ds by dt, or rate of change of displacement. So we will do for displacement, finding out displacement, we will integrate both sides and we can find it out like this. So for this we will use t I cap plus t j cap, set the limits 0 to root 3, and that would be t square by 2 plus t cube by 3 from root 3 I cap j cap 0 root 3. Yeah. So it would be 3 by 2 I cap plus 3 root 3 by 3, and this will cancel out and we will get this. So we have to take the magnitude. We have got the vector notation, we will find out the magnitude of velocity. sorry, what am I doing? This is not velocity, this is displacement. We got the vector notation, we will find out the magnitude. Yeah, so 9 by 4 and 3, and that would be root 21 by 2. So now we can find out distance. For distance, what we will need? We have the velocity. To find out speed, as we know, with this formula we can just find the distance using this formula, right? As we did it here, we will convert it into integration. So for that we need to find out the speed first. So how will we get speed? Simple. The magnitude of velocity is speed. So we know how to find out using vector calculations. So this will be t square. We taken the t square common and took it out. These are mathematical manipulations, you should know about it. And similarly, like previous one, this is distance, and this is speed, or I can write like this. Like this or like this, modulus. So now t plus 1 plus t square. Actually the manipulations would be done by you, I would advise. This is just simple substitution integration, so the answer would be 7 by 3. Okay, so here is the second question regarding acceleration. So this is the constant speed. A particle covers a half circle with constant speed. So it is a tangential direction to the circle, and this goes like this, and this direction is now here. Direction changes, the speed is same, but the velocity is different. So yeah, now we can see we have to find out the radius is r, and now we have to find out average acceleration. So the formula is v final minus v initial divided by time. So we don't know time here, so how we will find out? So as we know that velocity is, speed is distance by time. So what is the distance here? Distance is pi r, and t we have to find out. V is already given, so it would be pi r by v. And this is not speed actually, this is velocity. Okay, the average acceleration formula involves velocity, not speed. So here we can see this is xy plane, x here, y here. So this is pointing above. Okay, so this would be vj cap, yj cap, because the y-axis denotes j cap, it is only in the direction of y-axis. So this is j cap, and this is in the negative side, so this would be v but minus j, and we can put here v. Okay, now so minus plus 2v j cap by, and this will go up v square. This is 2v square by pi r. Thanks for watching.